Hi guys, welcome back to another exciting day of math. If you don't find it exciting, then I will greet you as hi guys. No, but we don't have time for that. Okay, so today we are going to continue to practice our favorite F word. Yeah, that's right, factor. Okay, but before we have more fun factoring, let's go ahead and introduce the X games. Okay, so X games, what are those? I guess we tossed in the X and then we say, hey, let's play a game. Okay, I'm going to give you some numbers and then you fill the rest. Okay, so scratch that. Okay, so we are going to go over the X games to facilitate our factoring unit. Okay, so let's do this. Anytime we play a new game, well, we have to know what the rules are. So it says rules. Find two factors of the top number that add up to the bottom number. Oh, I used my pen. Remind me to use my finger next time. Okay, so X game rules. So we have 4 entries. I'm going to give you the top, I'm going to give you the bottom, and then I need you to find the sides. Okay, so what are the rules? Find two factors of the top number that add up to the bottom number. So for problem A, I guess recycled again, we want factors of the top that add up to the bottom. So like using my math words, we want factors of negative 35 that add up to negative 2. Well, who speaks like that? So let me just write it out. We want factors of the top. Okay, so our sides are going to have to multiply to negative 35. We want factors of the top that add up to the bottom. And our sides will have to add up to negative 2. So I'm like, okay, so what are factors of negative 35 that add up to negative 2? So I'm like, what times what is negative 35? And at the same time, the sum of those two factors will give us negative 2. So I know that you know that 7 times 5 is 35. Cool, that's fantastic. But we want to get a negative product, so that means that one of these bad boys will have to be negative. Which one should be negative? Well, because the sum is negative, then we have to make sure that the larger factor is negative. Okay, but I don't trust myself, so I'm going to check it. Product of negative 7 and 5 is negative 35. Sum of negative 7 and 5 will give us negative 2. Fantastic. Now, what if you're like, can we switch the sides? Oh, most definitely. Okay, why can't we? The reason is because both multiplication and addition are commutative. So for multiplication, the order in which we multiply doesn't matter. For addition, addition is also commutative. The order in which we add does not matter. So if I give you an X game and I say, all right, knock yourself out, you can put the 7 and 5, well, negative 7 and 5 in any order of our liking. Okay, problem B. We want factors of 12 that add up to negative 7. So this is still new to me because we just have like 2-second practice. So I'm going to put the times and the plus. Okay, so we want factors of 12 that add up to negative 7. So I'm like, what times what is 12? And at the same time, the sum of those factors will give us negative 7. So I think it's 3 and 4. Okay, 3 times 4 is positive 12. Fantastic. But the sum is should be negative 7. And our sum doesn't give us negative 7. But I know that you know that the product of two negative numbers will give you a positive number. So the side should be negative 3 and negative 4. Or if you want to switch it out, you can put negative 4, negative 3. Either way, factors of 12 that add up to negative 7 are negative 3 and negative 4 in the order of your liking. Cool. Now, am I going to ask you these X games on the test? Of course not. Okay, we have cooler problems. Okay. So we're going to break up this unit across 2 videos. So this is part 1. We are going to be factoring trinomials of the form ax squared plus bx plus c. Okay, at a first glance, it looks like we have a bunch of variables, but we don't. Okay, the only variable that we have is actually the x. A, B, and C represent real numbers. So I want to point out that A is the leading coefficient, B is the coefficient of the middle term, and in this case, C is the constant term. If we were to have a second variable, then C will be the coefficient of that third term. So in the later video, we're going to factor something like this. 5x squared plus 3x minus 2. I'm not sure if that's factorable, so I'm going to leave it to the side. So let me identify A, B, and C. So in this case, leading coefficient is 5. That's our A. Coefficient of the middle term is 3. So that's our B. And that constant term is negative 2. That's our C. We are going to save these kinds of problems for part 2. Okay, for part now or part 1, we are going to look at the case where A equals 1. Oh, that's my favorite case. Okay, if A equals 1, let me go ahead and replace the A with 1. Then we have 1x squared plus bx plus c. But I know that you know that 1x squared is just the same as x squared. Okay, so what I want to point out, we are going to focus on energy on factoring trinomials that look like this: x squared plus bx plus c. If you want to impress your friends, you're going to tell them, hey, today we're going to factor trinomials whose leading coefficient is 1. Okay, fantastic. So we have lots of guidelines right here, but as always, I rather walk you through them. Okay, that's like a tongue twister for me. Okay, I need to minimize how many words I say. Okay, so fun problem number 1, that's gonna be our only set of problems, and then we'll do 8 problems for fun. Okay, so it says factor completely, if not factorable, so state. Remember, we need to have a clear idea of what we are being asked to find in order for us to have a fair chance. Factor completely, or factor, what does it mean to factor? Factor is code for right means a multiplication problem. So let's go ahead and do this. Problem A, we have x squared plus 10x plus 16. So in the earlier chapter, we spent so much energy like multiplying polynomials, and then now what we're doing, like, we're kind of undoing our work. You know, we're taking these answers and then we want to backtrack to multiplication problems, or in short, we want to factor. Okay, factor, what does that mean? Right means a multiplication problem. Okay, what is the first step when it comes to factoring polynomials, or in this case a 3-term expression or trinomial? To factor trinomial, the prerequisite step is always to watch out for common factors. Okay, what happens if you don't watch out for GCF? It's no big deal, but the thing is, you're gonna work with numbers that are larger than needed. Okay, so I recommend you watch out for common factors now, and then do what you gotta do. Okay, so let's see if we have any common factors to yank out, and in this case we don't. Fantastic. So I'm gonna ask myself, what kind of polynomial do we have? How many terms do we have? If we were to have 4 terms, how do we factor a 4-term polynomial? Oh, we would factor it by grouping. But in this case, we don't have 4 terms, so no grouping. We got a trinomial. I'm gonna cross my fingers, literally. Is the leading coefficient 1? It sure is. Okay, so I'm gonna jump for joy. How are we gonna handle it? So it says step 1, throw down parentheses and work on getting the first term in the trinomial. Okay, whatever that means. Okay, so let me break it down. We're going to throw down parentheses. How much space should we have between the open and close? Enough to fit a binomial. Okay, and then it says work on getting the first term in the trinomial. And the reason why I have F capitalized, because I'm thinking FOIL. You know, if we were to have something like this, x plus 2, x plus 3, we will say first, outer, inner, last. Okay, so throw down parentheses and work on getting the first terms. Okay, so I'm going to bust out my special effects that I did them like 2 minutes before the video started. Okay, the product of the first terms should give us the very first term that we see. So we have some options. We can either do 1 times x squared, or we can do variable times itself. I'm going to give you a suggestion. Always do variable times itself. Okay, so the product of the first terms, we're going to put x times x. Why do we put these x's in the first slot of each binomial? Well, that's because we're trying to backwards FOIL. Okay, the product of the first term should give us x squared. So this is why we put them in the first slot of each binomial. We're pretty much halfway done. Now what we need to do is complete the binomial factors. So how are we going to do that? The directions say find 2 factors of c that add up to b. So find factors of c that add up to b. Remember, this is a trinomial of the form. Where am I? I can't really project it because I don't want to drop my special effects. We are working with the trinomial of the form ax squared plus bx plus c. Okay, now if the leading coefficient is 1, this is how we're handling it. Okay, for the next video we'll talk about how do we handle it when the leading coefficient is not 1. Okay, so we have the binomial factors halfway filled out, but to complete them, we want to find factors of c that add up to b. Let me identify c and b wherever I have space. Usually I put the letters below, but I don't have space. So I'm like, okay, factors of c that add up to b. Factors of 16 that add up to 10. I know you're a genius and you're like, I'm on it. But to tell you the truth, I'm not quite sure. I'm a visual person. So if I don't write down my thoughts on paper, it's not going to come to me. So I'm going to go ahead bust out an X game. Now someone said, do we need to write the X game? No. If you can spit out the answer, go for it. I'm going to set up the X game. We want factors of C that add up to B. So factors of 16 that add up to 10. So I'm like, okay, factors of 16 that add up to 10. If you need to remind yourself, like what the operations are, the side should multiply to the top and the side should add up to the bottom. So I'm like, factors of 16 that add up to 10. I'm like, 4 times 4. No. Okay, this is a slow process. So I'm going to show you how I do it. I'm going to go ahead and do a factor table. Okay, I'm going to put the 16 on top. So factors of 16 that add up to 10. And then we're going to list all the factor pairs in order starting with 1. So we have 1 times 16 is 16. But I'm going to ask myself, is the sum 10? Nope. Okay. 2 is a factor. 2 times 8 is 16. And lucky for you, the sum is 10. So thanks to our hard work, we're going to tell the world that factors of C that add up to B are going to be 2 and 8. Now, how are we going to handle it? The sides in your X games are the numbers that you're going to use to fill in the parentheses. So one side number is 2. So one binomial should read X plus 2. Another side number is 8 or positive 8, so the other binomial should be 8. Okay, we already watched out for common factors in the beginning, but I'm always paranoid, so I watch out for common factors at the end. X and 2, no GCF other than 1, ditto for the second binomial. Again, what were the directions? The directions were factor completely. Factor, that's code for write me as a multiplication problem. We have a multiplication problem and we broke it down or we factored it all the way, so we're good. Now the question is, how do we check it? So to check it, this will be the only problem that we're checking. So make sure you're not asleep. Okay, so to check it, we're just gonna FOIL it out. Okay, we're gonna multiply it back out. After we multiply it back out and we combine like terms, if any, then we should get the original expression. Okay, product of the first terms gives us x squared. Product of the outer terms will give us 8x. Product of the inner terms will give us 2x. Product of the last terms will give us 16. And if this doesn't give me the original trinomial, I'm gonna start crying. Okay, when we combine the like terms, sum of 8x and 2x will give us 10x. And look at that. Okay, no tears. Okay, I am happy. Let's do a wink. All right, so that gives us the original trinomial, so we know we nailed it. Okay, so I'm not expecting for us to be a pro after one problem. I know it seemed pretty cool. Okay, especially coming from what we did. But let's go ahead and do 7 more and then we're out for the day. Okay, problem B. So problem B, where am I? We have so we have x squared minus 11x minus 60. Okay, so I'm like, okay, what kind of polynomial do we have? Oh, 3 terms, trinomial. Cool. Prerequisite step, do we have a common factor to take out? Well, I'm supposed to say factor out, but you understand me. No, there's no GCF to factor out. Trinomial, is the leading coefficient 1? I'm crossing my fingers. Is the leading coefficient 1? It sure is. Okay, if the leading coefficient is 1, we're gonna go to attack mode right now. Let's go ahead, throw down parentheses, work on getting the product of the first terms, and then fill in the binomial factors. Product of the first terms, no more special effects because they take a while, and plus I don't think they're very nice. Okay, product of the first term should give us x squared, and we're always going to use variable times itself. When in doubt, check it out. Oh, look, I should have just let it go. All right, product of the first terms, x times x will give us x squared. We're halfway done. Now we want to complete the binomial factors. To complete the binomial factors, you want factors of c that add up to b. Remember, this is a trinomial of the form ax squared plus bx plus c. Okay, so we want factors of c that add up to b. If you're on it, you can go straight to answer. Work is not needed, but I'm not on it. I love the x game. There's something about me writing the x game that facilitates for me to see those numbers. So we want factors of c that add up to b, factors of negative 60 that add up to negative 11. So then I'm like, all right, factors of 60 that add up to 11, well, negative 11. So I'm like 10 times 6. No, and to tell the truth, I cannot think of another factor pair right away, so I'm gonna waste so much time. If you have access to a calculator, you can knock out these x games under a minute, okay? So we have factors of negative 60 that add up to negative 11, and we're going to list all the factor pairs in order. If you do a factor table, you need to list the factor pairs in order, else you're not going to know like if you've exhausted all possibilities, okay? So we have 1 times 60 is 60. One of them should be negative. The larger factor should be negative. This sum is nowhere near negative 11. 2 is the factor, 2 and 30, but the sum is not negative 11. 3 is a factor, it'll be 3 and 20. 4, I'm not quite sure. Someone punch it in for me. Oh, I don't have an audience today, so I'm my own audience, okay? So we have, where are we? Okay, so if I want to know if 4 is a factor, we're just going to take 60 and divide it by 4. If it gives you an integer, cool, then it's a factor. And if it doesn't give you an integer, it's not a factor. So drum roll. Alright, remind me not to do that again, okay? But it looks like 4 is a factor, and it'll be 4 and 15, okay? So it's 4 and 15, and check it out. The sum of 4 and negative 15 is negative 11. So 4 and negative 15 are our winners. Remember, you're more than welcome to switch the sides. It doesn't matter. If you switch the sides, then your binomial factors will be flipped, and it's okay. The book may not read your mind. So as long as you have both factors, you're good. The order doesn't matter. Okay, so let's plug them in. One side number is positive 14, so one binomial should read positive 4. One side number is positive 4, so one binomial should read x plus 4. Another side number is negative 15, so the other binomial should read minus 15. And we're going to pretend like we checked this already, okay? We don't have time. Oh, that's like a really big space. That's not good, okay? Pretend I fixed them, okay? So that's 2 problems down. 2 more, oh, not 2 more, 6 more to go. Okay, keep track. We're doing 8. Problem C, we have x squared minus 15x plus 36. Alright, so the first thing we need to do is watch out for common factors, but we don't have any. Cool. Trinomial. Is the leading coefficient 1? I hope so, okay? So in this case it is. So if the leading coefficient is 1, we're going to go to attack mode, okay? Throw down parentheses. I put too much space. Throw down parentheses, work on getting the product of the first terms, and then complete the binomial factors. Product of the first term needs to give us x squared, and in this case x times itself will give us x squared. To complete the binomial factors, we want factors of c that add up to b. So I'm like, okay, what are factors of 36 that add up to negative 15? If you want to go straight to answer, go for it, but I'm going to show some work. So we want factors of c that add up to b. Factors of 36 that add up to negative 15. I'm going to pretend like I did a factor table, okay? But someone help me out. I don't know the answer. Okay, it's 12 and 3. I was going to pretend like I knew it, but I didn't. But then I just guessed correctly. Okay, so you don't have to do a factor table. If the numbers come to you, cool. And if the numbers don't come to you, go ahead, bust out a calculator and do your factor table. Okay, so let's go ahead, get our answer so we can almost leave. So the binomial factor should read x minus 12 times x minus 3. X minus 12 times x minus 3. Cool. Alright, so that's number 3. So I don't know how much we have left, but we're doing a total of 8. Problem D, we have x squared. I have a spicy one for you. Minus x minus 168. Are you going to see this on the test? Of course you will. Alright, so let's do this. So, again, directions, factor. What does it mean to factor? Factors, code for write me as a multiplication problem. Is that the one I wanted to do? I guess so. Okay, cool. So let's do this. So factor, write me as a multiplication problem. Prerequisite step when it comes to factoring is to watch out for common factors. We don't have any, so we're good. How many terms do we have? 3 or tres. Alright. When we have a trinomial, I'm going to cross my fingers and I'm going to ask myself, is the leading coefficient 1? It sure is. If the leading coefficient is 1, let's go to attack mode. So let's go ahead, throw down parentheses. Now someone asks, what if the leading coefficient wasn't 1? Well, check it out. If it's not 1, then we're not gonna go to attack mode and you gotta come back for the second video. Okay, so we throw down parentheses, work on getting the first term. The product of the first term should give us x squared, and in this case we're gonna use variable times itself. To complete the binomial factors, you know the drill. We want to find factors of c that add up to b's. Let me highlight the value of b. We want to find factors of c that add up to b. So I want to find factors of negative 168 that add up to negative 1. Again, the x game is not necessary. If you can just do it mentally, go for it. But this number is out of my zone, so no, I need to write it out. Factors of negative 168 that add up to negative what? No idea. So what am I going to do? I'm going to do a factor table and bust out my calculator. So let's list these factor pairs in order from smallest to largest. So we know that 1 is a factor because 1 is a factor of everything. Product should be negative, sum is negative, so the larger factor once again is negative. 2 is a factor, we punch it in, it'll be 2 and 84. Is 3 a factor? No idea. Okay, so again, I'm by myself today, so I'm my own audience. So we have 168 over 3. That gives us 56. You know what? I'm going to put this calculator to the side because we have too much glare. Okay. This one has glare too, but it's okay. At least you can see. So 168 divided by 3, that gives us an integer, so it's a factor. So it'll be 3 and 56, but it'll be negative 56. And what's the sum that we want? Negative 1. Okay. Is 4 a factor? Now, if you choose to use a calculator to find the side numbers, you don't have to write out the factor table. But again, we love math, or pretend we do at least. Okay, so we want to put like our thoughts. We want to put our thoughts like if it was a math diary. If the only thing you write in your notes is just the answer, how helpful is that gonna be? Okay, this is why we speak to ourselves. Okay, I digress. Okay. Okay, 4 is a factor. It'll be 4 and 42, but again negative because larger factor is negative. That sum is nowhere near negative 1. 5 is not a factor, but when I get nervous I gotta punch it in. Okay, that's not an integer, so no. Is 6 a factor? No. Okay, but that sum is not negative 1. Is 7 a factor? Who knows? Oh wow, look, it is. 7 is a factor. Is 8 a factor? Oh, punch it in wrong. 168 divided by 8, it is a factor, but that sum is not negative 1. Okay, I'm running out of space, so what am I gonna do? I don't want to have a long table because I need to make space for more problems, so I'm gonna go ahead continue the factor table. Is 9 a factor? Nope. Is 10 a factor? No, because we're cool like that, but then when I get nervous I forget. Is 11 a factor? Oh, when is this madness gonna stop? It is gonna stop when we find the answers. Okay, is 12 a factor? Yes, cool. Hopefully this is a winner. Sum is negative 2 and we want a sum of negative 1. Okay, so maybe the next one is a winner. Okay, is 13 a factor? It is not. Is 14 a factor? It is, but check it out, it's already in our list. Okay, so I'm gonna point out the importance of listing the factor pairs in order if you go the table route. If you just put the factor pairs in any order of your liking, what if it turns out that there's no solution to the X game? If the factor pairs are not in order, you will never know for sure, like if you didn't find the factor pair or if it just doesn't exist. If you list the factor pairs in order, I'm assuming from smallest to largest, once you hit a factor that's already in your list, then you know you've exhausted all the factor pair possibilities. Now, what is going on? X game has no solution. So let me, again, we write in our math diary, okay? X game has no solution. Is the answer no solution? No, because if I give you a trinomial and I say, quick, factor it, and you say, oh, X game has no solution, I'm going to be like, whoa, where'd that X game come from? Okay, we have a trinomial, we are asked to factor it, and this is how it's going to go down. If the X game has no solution, then that means that the trinomial is not factorable. pretend I wrote down all those words, okay? For those of you that want to put a longer journal entry, then you just write, you know, like love notes. You say, since the x game has no solution, then that means that the trinomial is not factorable. Okay, so the moral of the story is this: how can I tell if a trinomial is factorable? Okay, so check it out. If the corresponding x game has a solution, then the trinomial is factorable, and then do what you gotta do. But if you go the x game route and the x game has no solution, then that means that the trinomial is not factorable. What does it mean that it's not factorable? So when I asked you to factor, that is code for write me as a multiplication problem. But if it's not possible to write down as a multiplication problem, then we just write not factorable. Okay, depending on the book, it may say prime or prime polynomial. I don't like these words because they don't really resonate with me. Like if it's the directions say factor and it's like, oh man, I can't, not factorable, that resonates with me more. But I don't really care, not factorable or what your book says, prime or prime polynomial. Okay, I lost track, but we're doing a total of 8 problems. Okay, so here's problem E. E, we have, check it out, a spicy problem. 2x cubed minus 6x squared plus 16x. Okay, if you can see my face, you would see that I'm having a moment. Why? I'm having a moment because the leading coefficient is not 1. I'm crying. Okay, oh, I did my expression like if you were seeing me, like if I'm in class. Alright, we do have a trinomial, but unfortunately the leading coefficient is not 1. Does this mean that we're gonna start video 2? Of course not. Okay, so prerequisite step is to watch out for common factors. All these terms have a common factor of 2. All these terms have some x's in common and 1x. Okay, so altogether the greatest common factor is 2x. Do you have to write down GCF equals 2x? No, the directions just read factor. If it says the directions read what's the GCF and then factor, then yeah, you will have to write it. But the directions just read factorable. The directions just read factor. Okay, I choose to write this out to remind me why is it that we put the 2x. So a prerequisite step, factor, watch out for common factors and factor from the expression. So let's do this. 2x cubed divided by GCF will give us x squared. Negative 6x squared divided by 2x will give us negative 3x. 16x divided by 2x will give us 8. Whew, we factor. Okay, but now the question is, can we factor more? Okay, I don't know, maybe. So I'm going to assume that we can until we realize that we cannot. Okay, so now we have a trinomial still. Is the leading coefficient 1? I'm crossing my fingers. I hope so. Okay, again, I'm going to assume that the trinomial is factorable until I realize that it's not. Okay, so let me go ahead, throw down parentheses and all that good stuff. But I'm very forgetful, so I'm going to go ahead, bring down my GCF because I will hate to do all the muscle but get dinged on technicality. Okay, so let's do this. So to factor a trinomial whose leading coefficient is 1, we're going to throw down parentheses, work on getting the product of the first terms, and then we're going to complete the binomial factors. So we have x times x will give us x squared. To complete the binomial factors, we want factors of c that add up to b. If you don't need the x game, I don't need the x game. Okay, factors of c that add up to b. Factors of 8 that add up to negative 3. So I'm like, oh, okay, what are factors of 8 that add up to negative 3? So I'm like, 2 and 4, 1 and 8, nothing works. I don't want to go straight to like it's not happening because I'm going to do a factor table. Before I'm quick to say that the trinomial is not factorable, I will always back it up with the factor table for my peace of mind, not for the grader's peace of mind. Okay, so let's list all those factor pairs. So 1 times 8 is 8, but the factor should be negative. Okay, so negative 1 times negative 8 is positive 8, but the sum is not negative 3. Okay, next factor, 2 is a factor. Product is positive 8, sum is not negative 3. 3 is not a factor, 4 is, but it's already in our list, so we're gonna stop. Okay, so what's the moral of this story? The X game has no solution. So I'm gonna put a little love note. Okay, X game has no solution. Since the X game has no solution, that means that we cannot factor the resulting trinomial. Okay, but I want to point out the difference between problem E and problem D. Okay, problem D, we were not able to write problem D as any kind of multiplication problem. So this is why we said that the trinomial was not factorable. Problem E, were we able to factor it? Were we able to write it as a multiplication problem? Yeah, 2x times this. We weren't able to break it down more like we expected, but the question is, were we able to factor it? Were we able to write any kind of multiplication problem? And the answer is yes. So please do not write not factorable. So I'm just going to write down the answer. Okay, 2x times x squared minus 3x plus 8. Cool. Okay, how many problems are those? I don't know, but I say we're doing 8. So what's after E? F. I don't know how to count. Okay, I lost track, but we're doing 8 problems. So let me get another sheet of paper. Okay, so problem F. Problem F, we have, where am I? Okay, so we have negative n to the third power plus 16 n squared p plus 420 np squared. Is this spicy problem? Yeah, it sure is, because this is problem F, not problem A. Okay, but not to fret or whatever that means. Okay, prerequisite step is to watch out for common factors. Okay, so I see some n's and some p's and some other good stuff. So all terms have some n's, but the question is, how many n's do they have in common? We got 3, 2, 1, so just one n in common. I also see some p's, but the first term doesn't have a p, and there's no integer factors to take out. So the GCF is just n. Now, from an earlier video where we practiced factoring out the GCF from the expression, I had said the biggest recommendation I can give you is this. When you take out a common factor, it would be nice if you started on a positive note. Like, who cares if the rest are negative? So instead of factoring out a positive n, we're going to go ahead factor a negative n. Okay, so let's do this. First term over common factor will give us n squared. And again, if you need to do a thinking area, you know, you're like, oh yeah, negative n cubed over negative n equals positive n squared. Go for it. Do what you got to do. Second term over common factor will give us negative 16np. Third term over common factor will give us negative 420. N's cancel. P squared. Cool. So we have factored. What does it mean to factor? Factor is code for write me as a multiplication problem. But the question is, can I factor more? And you know my drill. I'm going to assume that we can until we realize that we cannot. We got a trinomial. I'm going to cross my fingers. Is the leading coefficient 1? It sure is. Okay. How are we going to handle it? Please don't let that second variable scare you. Well, it could scare you, but don't let it stop you. Okay. So they say face your fears. It's a lie. Okay. So I'm going to just cover it up. And I'm going to pretend like we didn't have that second variable. Okay. So let's do this. So if we didn't have that second variable, let's go ahead and do this. We're going to go ahead, throw down parentheses, and focus on getting the first term. But I told you, me and my forgetful mind. Okay, bring down your GCF. So we're going to throw down parentheses and work on getting the first term. Product of the first terms will give us n squared. So we're going to do n times n. To begin to complete the binomial factors, and I say to begin because I'm temporarily ignoring the p. Okay, to begin to complete the binomial factors, we want factors of c that add up to b. Okay, depending on your book will say that c is 420p squared, but I don't really like that because that's gonna bring us into a lot of problems when we do other stuff. Okay, so yeah, for me, a, b, and c are numbers. Okay, well, that's it. Okay? So we want factors of c that add up to b. We want factors of negative 420 that add up to negative 16. Can I spit them out off the top of my head? Of course not. Okay, let's do an X game. We want factors of c that add up to b. So factors of negative 420 that add up to negative 16. Okay, if you got a calculator, you can give me the answers, but I'm going to pretend like you don't. Okay, so let me do a factor table. So factors of negative 420 that add up to negative 16. You don't have to write down your calculator keystrokes, but I told you why I do. So 1 is a factor, it'll be 1 and 420, and in this case the larger factor will be negative because the sum should be negative. 2 is a factor, I'm just not quite sure, it'll be 2 and 210. 3 is a factor. Oh, I said that prematurely, right? That's because I'm cheating. Okay, 4, I'm not sure if it's a factor. It's 4 and 105, but that sum is nowhere near negative 16. 5 is a factor because we're cool like that, but you know, same speech. Is 6 a factor? Maybe. I think it's 70. All right. Oh, look, I'm so smart. Okay, cool. I need to start a new table because I'm running out of space. Is 7 a factor? Yeah, I think it's like 60. Okay, but don't quote me on that. But that sum doesn't check out. Is 8 a factor? Who knows? That's how we have a calculator. No, it's not. Oh, look at me prematurely. Is 9 a factor? For those of you like, oh, we know the answer. Well, you're not talking to me. I am by myself. Oh my gosh, I need to pause. Alright, is 10 a factor? I amuse myself. Alright, 10 is a factor, but the sum is not negative 16. Is 11 a factor? It is not. Is 12 a factor? For those of you that like to text, this is a really good opportunity. You just go like this and then you're good. Alright, let's go ahead and erase all of that. Okay, where were we? 12. Is 12 a factor yet? You know what? This could be our winner. What's 12 plus negative 35? Oh no. Okay, we're at negative 23. Let me just speak to myself. Sum is negative 23, which is not terribly far from negative 16. So maybe the next one is a winner. Okay, is 13 a factor? Nope. Is 14 a factor? I'm getting tired, so it better be. Yeah. So let's go ahead, check it out, see what the sum is. So 14 plus negative 30, that gives us negative 16. Okay, I like to vent my emotions. Okay, so the numbers will be 14 and negative 30. Okay, so to begin to complete the binomial factors, one side number should read positive 14 and the other side number should read negative 30. But check it out. Oh, I'm gonna bring back my special effects. If we were to FOIL it out, the product of the first terms does give us n squared, but the product of the outer terms gives us negative 30n, and it should give us something like np. The product of the inner terms gives us 14n, and it should give us something np. But what I want to point out is this: the product of the last terms, if you got a calculator, 14 times negative 30 gives us negative 420. It doesn't give us negative 420p squared. So the question is, how are we going to get the p squared part? We're going to get it the same way we got the n squared part. Variable times itself. So we need to insert some p's. Okay, where? Negative 420p squared is the last term in this trinomial. So how do we calculate the product of the last terms? Okay, we put our fingers. The product of the last term should give us negative 420p squared. We got negative 420. We need the p squared part. So let's go ahead and insert the p squared part. We're going to write p times p. Okay, so if we were to FOIL it out, that's the answer. So let me just box it. Okay, so if you wanted to check, we would just FOIL it out. So I said we were only going to check one problem, but I think this one is worthy of checking. So you check it however you like. I recommend that you multiply the binomial factors and then you distribute the negative n. Product of the first terms gives us n squared. Product of the outer terms is negative 30 np. Product of the inner terms will give us positive 14pn, but love yourself, put the letters in alphabetical order. Product of the last terms now gives us negative 420p squared. Let's go ahead, bring down the rest of the problem. Don't distribute just yet. Go ahead, combine the like terms. The sum of the middle terms, namely negative 30np and positive 14np, will give us, I'm going to cheat, negative 16np. Bring down the rest of the problem. Let's go ahead, distribute. When we distribute, that will give us negative n cubed plus 16n squared p plus 420np squared. Now this was like a long process, so if it doesn't check out, I'm gonna start crying. Okay, so remember, there's no partial credit on our assessment, so please check your answers whether you do it on paper or elsewhere. Okay, problem G. Oh, it's like the never-ending story, but you know what, you will thank me. Okay, if you need to pause and come back, YouTube will know where you picked up. All right, problem G. We have 6 times m to the 9th n squared minus 60 m to the 5th n to the 4th plus 150 m n to the 6th. Okay, hopefully I said that right. First thing we're going to do is watch out for common factors. 6, 60, and 150 are out of my comfort zone, so I'm totally going to use the latter. Okay, so reference from an earlier video. Let's write our numbers in a horizontal format, and then with the use of our calculator, we're going to quickly find the GCF. You divide by the first thing that comes to mind. To me, I'm like, they're all even, so I'll do 2. Some of you are like, I'll do 6. Yeah, go for it, but I know that 6 goes into the first 2, but I don't know if it goes into the last one. So again, if you divide by the first thing that comes to mind, you will finish sooner than later. 2 goes into 6 3 times, into 60 30 times, into 150, punch it in 75 times. 3, 30, and 75, I'm not quite sure. Since 3 and 30 have a common factor of 3, I'm going to see if 3 goes into 75. Oh yeah, 3/4. Yeah, it does. Okay, let's go ahead, divide again, and that will leave us with 3 goes into itself once, 3 goes into 30 10 times, and 3 goes into 75 25 times. Our leftovers don't have any factors in common other than 1, so remember from back in the day, GCF is given by the product of all the numbers to the left of the ladder, namely 2 and 3. Okay, so thanks to us writing our thought process on paper with confidence, we're like, oh yeah, the GCF for the coefficients is just 6. So we know that the terms have a 6 in common. What else do they have in common? Okay, so we have some m's, 9, 5, 1, and it's just going to be one factor of m in common. We also have some n's, I think 2, 4, 6. Who do we appreciate? Yeah, all right. I was never a cheerleader, but maybe I should have been. All right, cool. So let's go ahead. I think we have 2 n's in common. Go ahead, put open parentheses. Take your time. Tell me what you're left with when you factor the GCF from the expression. First term over common factor, the 6's cancel. Quotient of the m's will leave us with 8 of them. Quotient of the n's, they're out. Next term divided by common factor, negative 60 over 6 will give us negative 10. Quotient of the m's will give us 4 of them. Quotient of the n's will have 2 of them. Well, you know what I mean, okay? Third term divided by common factor, 150 divided by 6. If we use our work, our table says that 150 divided by 6 is 25. Okay, if you don't trust yourself, then punch it in. Okay, quotient of the m's, they cancel. Quotient of the n's, they'll leave us with 4. So it's like, whew, we factored. I hope this is not factorable, but it probably is. So we have a trinomial. Is the leading coefficient 1? Yes. At a first glance, I will be happy because the leading coefficient is 1. But then I realized the degree is not 2. The degree is 8. Okay, where am I? I lost myself. The degree is not 2. The degree is 8. But it's okay. If you have a trinomial and the leading coefficient is 1, let's go ahead, just do the same speech. Okay, we're going to throw down parentheses. Focus on getting the first term. Okay, before I forget, I don't want to lose points due to technicalities. So let's bring down the GCF. Product of the first term should give us m to the 8th. Now, if this was m squared, we'll be like, we're on it. Variable times itself. We want two factors, okay? So in this case, we're going to take this exponent of 8 and divide it by 2. So let me go ahead and bust out a thinking area. We're going to take the exponent of 8 and divide it by 2, and that will leave us with m to the 4th, okay? So we have m to the 4th times m to the 4th. So I'm going to ask myself, is the product of the first terms, does it give us m to the 8th? Yeah, m to the 4th times m to the 4th will give us m to the 8th. Cool. So now let's go ahead and work our magic to complete the binomial factors. So you know my speech, I'm going to temporarily ignore the second variable. Okay. To begin to complete the binomial factors, we want factors of c that add up to b. Factors of 25 that add up to 10. If you're like, Amane Torres, I said my name. Okay. Factors of 25 that add up to negative 10 are negative 5 and negative 5. Okay, so again, if you don't need the x game, I don't need it, but I was just trying to show off. I do need it for me. Okay, factors of c that add up to b. Factors of 25 that add up to negative 10, negative 5, and negative 5, and we put them in. Okay, so the product of the first terms will give us m to the 8th. Okay, now I have to face my fears and look at the other variable. The product of the last terms gives us 25, but we want 25 times n to the 4th, so we're missing some n's. So I'm like, are we going to do variable times itself? No, because n times n is n squared. So again, because we want two factors, just take that exponent and divide it by 2. When we do, that will give us n squared. So let's go ahead, tag along that variable. Okay, so the product of our last terms, thanks to your hard work, will give us 25 n to the 4th. And if you FOIL it out, you will realize that the sum of the middle terms will give us negative 10 m to the 4th n squared. Cool. So this is our answer. I will take it for full credit. The popular question that I get, or comment that I get, is this: oh, can we write it with an exponent so we can like knock it out faster? I'm gonna tell you this. This is factored completely. You cannot break it down. Anything that you write thereafter is not gonna save you time. It's gonna cost you time. Okay, but I'm gonna tell you what the book says. Okay, the book will usually write exponents for repeated factors. So they will write 6m n squared times, and they'll use exponents for repeated factors. So it'll be m to the 4th minus 5n squared, and then we square it. Okay, so the book cannot read your mind. Okay, if you're looking at your answer, if you're checking your answer against the answer key, did I say that correctly? If you're checking your answer against the book's answer key, this is the book's answer, and then you want to ask yourself, well, is that my answer? I don't know. Do I have a 6mn squared? Yeah. Oh man, we have some binomials. We got 2 of them. Do I have 2 of these? Yeah, I have 2 m to the 4th minus 5n squares. Okay, so I don't care how you give me the answer. It's personal choice. Okay, final problem of the day. Oh, good, because we got to go. Problem H. We have 9x to the 7th plus 36 x to the 4th minus 189x. Fantastic. Cool. So am I having a moment? Of course I am. Okay, because these exponents are pretty intimidating. Okay, first things first, that doesn't look like an x. First things first, we need to watch out for common factors. For the coefficients, I'm not quite sure. Okay, so we have 9, 36, 189. Okay, 9 and 36, I know they have a common factor of 9, so we're gonna punch it in to see if 9 goes into 189. I think it does 1 times, or 21, how normal people speak. Okay, so yeah, we're gonna factor out a 9 or divide by 9. 9 goes into itself once, into 36 4 times, and into 189 21 times. Okay, so let's do this. So for the coefficients, the GCF is 9. All terms have some x's, but the question is how many x's do they have in common? Okay, the first term has 7 factors of x, 4 and 1. So overall we just have one factor of x in common. Okay, so let's go ahead and see what we're left with when we factor the GCF from the expression. First term over common factor, the 9's cancel out, and that will leave us with 6 factors of x. Second term over common factor, 36 over 9 is 4, and the quotient of the x's will leave us with x to the third. 189 over 9 gives us 21, will be negative, and the quotient of the x's cancel out. Okay, so we have factored. The directions are factored completely. So factor, what does that mean? Write me as a multiplication problem. We did, but again, we're going to assume that we can continue to factor until we realize that we cannot. Okay, we got a trinomial. Okay, leading coefficient is 1, so let's handle it. Okay, let's go ahead, throw down parentheses, and then work on getting the product of the first terms. Don't forget to bring down your GCF. Product of the first term should give us x to the 6. So I'm like, what times what is x to the 6? I don't have time to think. Okay, so I'm going to bust out a thinking area. Because we want 2 factors, I'm going to divide the exponent by 2. Okay, so that will give us x to the third. So it's going to be x to the third times x to the third. We put them in each first slot because the product of the first term should give us this first term. I'm very thankful that we don't have a second variable, so let's do this. To complete the binomial factors, we want factors of c that add up to b. Factors of negative 21 that add up to 4. And if my eyes don't fail me, I think there's a 7 and there's a 3 where the larger factor should be positive. Okay, but I always doubt myself, so I'm going to do an X game for fake extra credit. So we want factors of c that add up to b. Factors of negative 21 that add up to 4. And we had said 7 and 3 where the larger factor is positive. Okay, so one binomial should read x cubed plus 7, and the other binomial should read x cubed minus 3. Okay guys, I think we did it. Good, because these people want to be fed. Alright guys, have a good one. Thank you.